Today we are going to learn how to train your own custom dataset using YOLOv5. So basically, after the training, we will take a test image and run an inference process, and then we are going to detect all the objects in our model. In this example, this would be our results, and we can compare it to the source image. And if we put it side by side, you can see that I'm detecting a boat, a dock, and a lift. So those are part of our classes. I really recommend you to subscribe my channel and hit the bell button. More videos will be uploaded soon. So let's start. Okay, so let's start with the installation part. I will not do a full detailed installation, since you can find the full installation on this video. I will leave a link here in the upper corner so you can download and follow the full installation. This specific video tutorial is deal with YOLOv5 segmentation. However, all the installation process is basically the same. So I will leave a link for this tutorial. I also will leave an installation txt file, and you can see the first line in this installation file, name install.txt, points to this video tutorial. But let's cover quickly all the process. First of all, let's create a conda environment. Let's name it YOLOv5. It will be based on Python 3.8, and of course we will activate this environment. Then we will choose a folder, and we basically would clone the YOLOv5 repository as a subfolder under our folder. We can use I basically will use a tutorial folder, but you can choose whatever you like. Then we will clone the YOLOv5 repository, and the next process is choosing which version of PyTorch you should install in your local machine. So in order to do that, you should run this command, nvcc ---- version, and you can see what is your CUDA version. It should be something above 11. I'm using 11.8, but you can choose your own version. But it's really important, if we go to the PyTorch, let's find the PyTorch website, and if we go to all the install previous versions, you can see that the last one is 2.3, and this support 11.8. So if, for example, you have another CUDA version, let's go down for an earlier versions, and let's go down, for example, here, this PyTorch version 2.0.1 supports CUDA 11.7 and 11.8. So this would be the command in order to install it. Let's see another one. For example, if you have CUDA 11.6, you should install PyTorch 1.13.1. So this is the process. If I go back, I'm using 11.8, so I copy this command from the PyTorch website. Then you have to install a more relevant Python libraries that are required by the YOLOv5, like GitPython, Matplotlib, NumPy, and it's really important that the version will be above those versions. As you can see, some of them are above, some of them are not. You are not required to a specific version. However, when you installing the Ultralytics version, it should be this version for YOLOv5. Then you have to install OpenCV, but in order to do that, or before doing that, you should uninstall OpenCV headless, which is OpenCV without the visual functionality, and then reinstall the OpenCV with version above 4.1.1. So this is the installation part, and as I said earlier, you can follow my previous video that dealing with segmentation, but as I said earlier, the installation process is the same for segmentation and for object detection. Okay, let's continue to the next phase. So if you have done all the installation process, you should create a subfolder named YOLOv5. Mine is under the main folder tutorials. So if I go inside the YOLOv5, these are all the 5 that were cloned from the GitHub repository named YOLOv5. Okay, so let's go forward for the next step, and the next step would be downloading our dataset. So once again, I prepared another instruction txt file. As you can see, you have all the steps, and I will follow those steps in preparing our data for the train. First of all, this is the link for our dataset. As you can see, it's part of the RoboFlow website. So let's go to this website, and this is the same link, and you can see that we have about 500 images that are split to train, validation, and tests. Since we are using the YOLOv5 model, we will choose this one, the YOLOv5. Once again, sorry, this one, YOLOv5 PyTorch. You should click this button and then choose download the zip to your computer. What does it mean? We are downloading the images that are ready on a YOLOv5 format. So let's click continue, and as you can see here, all the images are downloaded and they are here in this section. So after downloading all the data, as you can see, I put it on my subfolder named Datasets, and I will rename this folder, the one that I've downloaded, to a more simple one. Let's call it Ariel-Maritime. Okay, so this would be our dataset subfolder. Let's open this folder. As you can see, we have 3 subfolders: train, validation, and test. We can see there is a file that named data.yaml. Let's open this file. So we have 5 classes, and these are the classes. So let's go back to our train images, and let's open the images folder, and let's go, for example, for this image. So this image contains our class, but once again, let's open the labels folder and open the second label, which indicates the same image, the second image. As you can see, we have here one object. This object is object in class number 2, and these are the points in YOLO format for the bounding box that indicates this object. So what is number 2? If we will go back to our data, that means this is 0, this is 1, and this is 2. So basically it's indicate this doc, which is class number 2. And if you go to another image, let's for example open the third image, you can see that we have 4 classes. Let's see this third image. We will go back to our folders of images, train images, and let's open this one. This is image number 3, and you can see we have here 1, 2, 3, 4 images, objects, maybe 5. Let's go back and see here. The training contains 2 objects with class number 2 and 2 objects with class number 4. Once again, let's go back and understand again. We have 2 objects of docs and two objects of numbers 4, 0, 1, 2, 3, 4, and two lifts. So basically this is the explanation for how the data was generated and stored for those images. So if we will go back for our task, the task is to detect those objects in these images. If we go back for our data YAML, 1 second, it's here, the data YAML, that's here. We have to update the full path for our train images. So we can just copy all the full path for our train images, that's it. And don't forget to change the direction of the slashes. And we will do the same for our validation. Valid, and that's it. And of course, don't forget to save it. Great. So in order to run the training, we have to go back to our command prompt. As you can see, I'm using Anaconda prompt. You can run Anaconda by searching Anaconda, and don't forget to right click and run as administrator. Next, you should be in your installed folder. I installed the YOLOv5 under C tutorials. You should go to your local folder where you installed the YOLOv5. And the last important thing, you have to activate the Conda environment that contain all the YOLOv5 Python libraries. You should do it by running the command conda activate and the name that you chose for this conda environment. Another important issue before we start the training, if you go to the YOLOv5 GitHub repo, you can see along with the nice documentation with this model, if you go down, you can see that YOLOv5 is separated or based on several pre-trained models. Each of those models has its own pros and cons, and basically it's the speed of training and the speed of inference. So there is YOLO5N, that N means nano, and the YOLO5S for small and medium, large, extra large. And you can see there are many types of YOLOv5 model. In our tutorial, we will use the medium. We will use this one. So once we start typing the command for the training, you will see that we are choosing this one, YOLOv5 medium. Let's continue to the next step. The next step would be the training. I already prepared an instruction file for the training as well. As I mentioned earlier, you should go to your local YOLOv5 folder and start the training inside this subfolder. So this is the command to run the training process. I will copy it and explain each of those parameters. So first of all, we are writing Python train.py. This is the Python YOLOv5 for training, -- data, and here is the path for our data YAML. Next, you should choose the YOLOv5 pre-trained model. As I mentioned earlier, I will use the medium, so it's a -- weights YOLOv5m.pt. It will download the weights automatically. Then what would be the image size for the training? 640. That means that all the images will be converted to this size for the training. Next is how many epochs we would like to run the model, so I chose 250. The next parameter is the batch size. That means in how many images will be included in each batch. It really depends on your GPU card. If you don't have any memory issues, you can try a higher value like 32 or 64. I discovered that 16 is good enough for our model. And the last argument is where we should store the results of the training. So minus name, and this is the name of the folder that will contain all the results of the training. So let's start. During the training, you can see that the YOLO model has been downloaded, and next there is a discovery of our training images and the validation images. And the model checks if they are corrupted, and you can see that our images are perfect and the training has started. You can see the progress for each epoch. Now it's epoch number 6 and now it's number 7. So it's going to run through 250 epochs. So let's fast forward and jump towards our last epoch and examine the results. So finally the training has finished, and basically before we will see the results and run a prediction on the test images, you should follow two values. The first value is object losses, and the main target of the object loss is that during the training this value should be decreased and go down. And the other value is this one, MAP50. This value should go up. So as you can see, if I go back during the training, these epochs are going up during the training, and the highest value here is 0.812. And then there is the final results. Here you can see for the validation images, please remember we have 105 validation images, and for each of those categories we can see what are the training values. So what is the precision and what is the MAP50. So you can get a good glimpse of the results of our model over our validation images. And the next important thing is to find where are the results. You can see here that the results are stored here in this folder. So in this folder we are going to find two types of weights. One contains the last results after the last epoch, and the second one named best.pt, which contains the best results out of all the running epochs. If we go to the folder, you can see that inside our datasets folder I have an all results, and there are some values here that we can cover. For example, if we open here this file named results, and let's see about our object loss, the one that we are expect that it will be decreasing, we can see that the results are great with the train object lost. And also if we go here to the weights, and we can find the best PT and the last PT, which indicates the best weights and the last weights. We can also see here another interesting results. If we open this image named val batch number 1, we can see that running the first batch of the validation images and running a prediction, you can see that it detected great. Here it detected a boat with a precision of 0.9, and also here detected cars and a dock in this image, and here it detected 3 cars, and here another boat. So basically the results seems okay, and these are results of the validation images during or after the training. So now let's continue for checking our model with a new and fresh images, our test folder. So let's continue to the next step, which is running a prediction. I'll also generate a new instruction file. So this file contains some explanation about the arguments for the detection. Let's copy this command. Also, all these files will be in a link in this video description. So let's run the inference of a specific image. Let's copy this command. What we are doing now, we are running a Python file named detect.py. We will send several arguments. The first one is the weights, and we are sending a full path of our best.pt weights. So this file was generated after the training. Then we will choose one of the images. So it will be the argument named source, and we are sending this image. Okay, this image, and we are trying to detect what are the objects inside this image. And then we are generating a new folder that contains the results with all the prediction objects along with this image. So before running, let's look for this specific image just to see our source image. I will go back to our dataset subfolder. Let's go for the testing images, and let's look for this specific image. Oh, you can see that all the images contain the same name, so let's grab the full name, this one, copy, go back to the folder, and let's look for this specific image. Great, let's open this image. So we are going to detect the objects inside this test image. So let's go back to our command prompt and wait. So as you can see, the results were saved in this folder. Let's go for this folder and look for the results. So it's here, result, and let's open the image, and now you can see both images. So let's reduce the size so we can compare one next to each other. And on the right side, this is the original image, and on the left side we can see that it detected a lift, a boat, and a dock. Very nice. I hope you enjoyed this tutorial. Thank you very much. You are most welcome to subscribe, and my channel, as more videos will be published soon. Bye bye.